Good afternoon, all of you. So our project for cloud computing is real-time analysis of Twitter hashtag using Apache Spark. These are our teammates. Next slide. These are the keywords which we will you will see in our presentation, like Twitter API, Apache Spark, Spark streaming, tweet analysis, Flask, Apex charts. Next slide. So we will go through all these contents one by one. Next slide. One of the biggest sources of data today are social networks like Twitter, Facebook, and Instagram. This means that for marketers, big data specialists, journalists, and other professionals, they are an extremely valuable asset. Twitter is one of the biggest social media websites today, where people tweet and interact with others about topics they like. So naturally, it has a very rich source of data. We can analyze these tweets to get interesting and important insights about people's opinions towards a particular topic or brand or sentiments of people, what people are talking about, and overall trends in the genre. Also, many time sensitive business applications today can harness the potential of real-time Twitter data and make decisions based on it in the fields of IoT application, network intrusion detection, or fraud detection. So we will be using Apache Spark streaming and real-time analytics engine to process tweets that are retrieved from Twitter API, and then we will identify the trending hashtags from the Spark processing, and finally we will represent this process data in the real-time dashboard using Flask web server framework. Next slide. So this is our overall flow diagram of the project. So first of all, we will get the tweets from through Twitter API in our client app. Secondly, after getting tweets in the client app, we will send these tweets to the Spark through socket.io. And in Flask, we will process these tweets. And after processing the tweets and getting the hashtag and their accounts, the Spark will send the process data to the Flask, where the front end will get these tweets and hashtag count to display in the dashboard. Next slide.
So from here, let me start. So from here on, I will be explaining about Twitter API version 2. So basically, this was introduced by the end of 2020, and it was built from the ground up from the ground up to be faster and have access to many new endpoints. It also comes with new features and data that can pull and analyze a lot of new functionalities that are useful for academic as well as scholar purposes. And there are two types of endpoints: recent tweet search that is accessible to all, and full tweet archive search that are for enterprises only. Can we go to the next slide? So here are a few limitations of the Twitter API version 2, that are 440 queries per minute can only be processed with a monthly cap of 500,000 queries. And we cannot get general tweets from Twitter. We have to get the tweets based on some keywords that we will give as our input. Next slide. So Samir will explain you about the code and the responses and the requests that we sent and received.
Yeah, so good morning, good afternoon, everyone. This is Samir Gupta, and I will going to explain about the code of this Twitter API, how we extracted the tweets from Twitter API. Yeah, is this text visible, clearly visible? Should I zoom in more?
Yes, Samir, it is visible.
Yeah. So what we are first of all, we are taking these four input terms from the argument, from the pass argument. The number of pages, here is the number of pages, here it is the number of pages, queries, the maximum and sleep timer. After this, we are setting the queries in this format, in this certain format. so that we can use it in a, we can clearly see this thing query. Here is the, from this we are kind of building the TCP connection of the Twitter API with the TCP connection with a socket. The next is this comes the, for each query that we are taking the tweet. We are basically passing on the 3 parameter, the next token, the query, and the maximum result to the token, to this function get tweet data. And in this function, the get tweet data, in this whole function, we are first of all taking connecting it with the Twitter API, and after it, we are taking that this query, which is returning, should have the hashtag, and must be in English language. The next is the end date and the end time that we are taking. Here, the next that we are doing is this the URL that we are creating using the parameter, using these 4 are the parameter that we are passing in the URL, the keyword, the end time, next token, and the maximum result. From here we are here it is the code for it, and we are creating the URL using these parameters. The next we are using this get response function in order to take on the output, that is in order to take the output that basically return the URL what is returning. We are storing it this JSON response file, JSON response variable, and we are returning this JSON response to our main function. The next is we are just sending these tweets to the Spark function, and thus the Spark will further take on from it. The two like the most important thing was that the request, the basically the keyword that were used in the request were the keyword, the end date of the tweet, the maximum results that we take in a page, the tweet fields, and the next token. And this is the response that we get from the Twitter API after we pass these keywords. Okay. Now,
So
Archie will explain about you the Apache Spark.
yeah, thank you, Samir. So right, so this next section will be taken over by me and Ritik. So Apache Spark is basically an open source unified analytics engine for large scale data and streaming processing. It is one of the most used engines for real time data processing and provides the option for continuous computations as data is continuously flowing through them. So we have used this to process the tweets using Apache Spark streaming to identify the hashtag counts basically. So what is Spark streaming? Next slide, please, Samir. Yeah, thank you. So Apache Spark basically provides 2 ways of working with streaming data. That is Spark streaming and Spark structured streaming. So Spark streaming is basically an extension of the core Spark API. Apache structured streaming is a distributed and fault-tolerant streaming engine that enables processing data in real time. It is built on top of Apache Spark SQL engine, which deals with running stream data. It is fault-tolerant, scalable, and ensures recovery of any fault as soon as possible with the help of caching and checkpoints. So yeah, over to you, Ritik.
Okay, thank you, Archie. Next slide, please, Samir. Okay, so my part was along with Archie was Spark structured streaming and Spark streaming. So I will be explaining to you why did we use Spark structured streaming and not. Am I audible?
Yes,
Am I
Yes,
audible?
Yeah, you are audible.
Okay. So my part will be why did we use structured streaming and not normal streaming, and to explain a few lines of the code. So before Spark 2.x release, we used normal streaming, but Spark 2 release actually introduced this new thing called structured streaming, which is actually way more high level and functional API than normal one. And it is based on the Spark SQL library, as Archie told us. And it is actually another way to handle a streaming with Spark, and it is in better way than normal Spark streaming. It actually uses data frames rather than working directly with RDDs. So it is actually more efficient and easier to code than normal thing. The received data is triggered and is appended to the continuously flowing data stream, and each row of the data stream is processed, and the result is updated to an unbound result table. So now how we want a result now depends only on us, like how we can fit into the memory, or we can print it to the console, and we can do many things from it. So next slide, please. Okay, so this was the structure actually. This is how the code was there. You can read this slide, but I'm going to explain the code. Samir, I will be sharing my screen now. So
Okay.
you can stop sharing. My screen is visible? Is my screen visible?
Yes, yes.
Okay, so first, okay, so there is a in the root directory of our GitHub repository, there is a spark app.py for file which does all these things. So after receiving the data from what we are saying, Samir and Abhay's Twitter API, what we are doing is first of all, we are using a session manager instead of a context manager, because this way we can have multiple users with the same context manager. So we are creating here a Spark session manager, and what we are doing is we are now, this line actually does take all the tweets, all the hashtags from the Samir and Abhay's Twitter API implementation, and we are actually splitting those hashtags each in each line, and then we are grouping them by count. And then finally, what we are doing is we are we are calling a function process row in it, and it will process each and every hashtag. What it will do is now, since we have a dictionary or word count of each hashtag after this group by and explode and split functions, we have a word count of each hashtag. So now what we are simply doing is we are sending the data to the to this REST API endpoint that was created by Utkarsh and Ronak, and we are just taking the response, nothing else. So after posting this the tweets to the data, Ronak and Utkarsh will take over. So just a second. Yeah, so now Ronak and Utkarsh will take over.
So yeah, Flask is a micro web framework, as we all know, that is written in Python. And it is classified as a micro framework because it does not require particular tools or libraries. It is based on Wuxoic WSGI toolkit and Ginger to template engine that supports extension that can add application features as if they were implemented in Flask itself. We use Flask as a server because Flask is a lightweight web application framework that is designed to get results fast and leave room to make the app more detailed in the future. With Flask, the project's code consists only of what developers put in it, with no unnecessary code responsible for features we don't use. In our case, Flask server collects the hashtag data from Spark, as the Ritvik told, and then we direct it to the front end. Next slide. So these are the REST APIs which we have created in the server. First one is the default get API that is used to render HTML template for the dashboard whenever the server starts. After processing Twitter's data, the Spark will send hashtag data to the server through post API, that is update data. After this, the front end will call get API, that is refresh data, to get hashtag from the server. These two APIs are repeatedly called by Spark and front end respectively to update hashtag count on the dashboard, and the dynamic updation on the front end is done by the Ginger to template engine. So now Utkarsh will tell about the front end and Apex chart.
Okay. Thank you, Ronak, for your insights on the Flask and its implementation. Now, with a fully working backend, we also need a visualization tool such as Apex Chart to analyze the data more easily. Apex Chart is a modern charting library that helps developers to create beautiful and interactive visualizations for web pages. It's an open source project licensed under MIT and is free to use for commercial applications. Apex chart has a NPM support and it's better with bigger data set, but not by too much. In our case, JavaScript calls the server API to get hashtag data, and then it passes to Apex chart API to get a responsive and a dynamic bar graph. Next slide. Now, in our implementation of trending hashtag dashboard, we created a dynamic Apex bar chart, which is loaded with options to provide responsive visualizations on the front end. Front end will call the backend server get API to fetch the trending top 15 Twitter hashtag with their corresponding tweet count. These data values are then passed into bar chart through series option, which you can also be seen in the code line 75. To get real-time visualization on front end, the get API will regularly be called in an interval of 2 seconds. This bar chart is also packed with an option of responsiveness, which means that if the screen resolution changes, the bar chart remains the same and visually readable, which is implemented on line 113 of the code. Next slide. Now in this slide, you can see that this is the demo result of the project. As you can see, the bar chart is dynamically changing as the Spark processes real-time data from Twitter API. Also, we can infer from this chart that Corona and Bitcoin hashtags are claiming first and second positions in the trending hashtag index all over the world. Next slide. So what is the purpose of this project and where it can be useful? So this project can be useful to market a particular product by associating it to a trending hashtag. It is also useful to promote contests and giveaways to boost user engagement. It can also be useful to raise awareness about a particular topic, also to discover trending topics, and also to build a community around a hashtag. Now I would like to call Ritvik to present a real-time execution of this project.
Yeah, thank you, Utkarsh. Am I audible?
Yeah.
Okay, so this slide is for understanding the code. I will be doing a real-time presentation. So there are particularly two ways to run the project. One is the automated script, which I will be doing in the starting. Run.sh, you just clone the repository and run this script run.sh after reading the README file. It does exactly the same thing, which I will be doing in the second part. So if I run this project, this will automatically open it. And all the things that are doing here, I will be doing it manually in the second part. So let me just kill it because it's not useful to get all the output in the same terminal window. In the second part, what I will be doing is I will be manually running the thing, which is same as the script. However, the advantage is that you can see the Spark output in a separate window and the Twitter hashtag, Twitter app output in the separate window. So, and I will be opening now Python 3 app. This is the Flask server that I'm running, this thing. So the Flask server is accessible on localhost 5001. And now I will be running Python 3 Spark app, and in this terminal I will be running Python 3 Twitter app. Okay, so these three steps that I am manually running are automatically performed by the script. So yeah, this is waiting for the TCP connection from the Spark app, and as soon as I start the Spark app, this is the Spark window. Yeah, okay. So as soon as the connection was established, it started processing things from Twitter. The Spark is doing stage 1 processing, and these are the hashtags that are received from the Twitter. So it is printing it actually. Currently, it is on page 7 for keyword Corona, page 8 for keyword Corona. After the Spark app has processed stage 1 and stage 2, it will send it to the front end, and then only it will update. So these were the what we can say count and hashtags that were took that Spark sent to the front end, like New York was 2 and things, and this is the dashboard which is updated in real time. As usual, the Corona and the Omicron variant, which was just discovered last week in the international markets, are on top, COVID and this. And now after what we can see is it is processing page 13 for Bitcoin. Now, as soon as the Bitcoin and gaming keywords are coming, they are also in the top trending. So they are being shown here. And if you look at the Spark output, we can see that it is processing hashtag and its count quite beautifully, and count 10 and all these things. It is sending it to this. To stop the project, we just have to run kill all Python 3 and all of these things are stopped. So this was from my side, and these are the references from where we took all the code and we read about things. Most of them are basic Spark documentation and other things, and Epic Start documentation we did. So thank you. Is there anything else we would like to present?
No.